Good morning, everyone. My name's Ken. I'm sure many of you encountered me over the past few years around and about the IOTSF conference. Now, one of the things that many of you may not know about us is that whilst over the last few years we've talked a great deal about the Internet of Things security, and you'll have seen lots of our entertaining and perhaps slightly scary research into IoT, we came from a background in OT, in operational technology or industrial controls. DCS or SCADA are some of the acronyms you've probably come across too. So it's fascinating when you start to see two areas of great interest for you start to join up. And that's what I want to talk about today. I want to talk about the industrial Internet of Things. Now we talk about IIoT. I'll be honest, I don't really like that acronym. What I do like is the idea of OT or industrial controls becoming increasingly connected. And that's what my talk's about today. Is I'd like to walk through some of the issues we've seen in IoT, and do you think we might see the same mistakes starting to happen in industrial control systems? And I think it's a real shame because many of the learnings that we've made in IoT security over the last few years don't seem to be being applied into OT. So let's go into that. So just a little recap there. So our background, believe it or not, is actually in OT. So many of the team here come from an OT background. So we have people who used to run real-time system security for a large electricity provider. We have people who used to run the control rooms in a gas provider, and others who used to run real-time system security in water utilities, for example. So again, it's not something we've really shouted about a lot because we've taken those skill sets and moved them into IoT, but actually it's really interesting. You probably know us if you haven't come across us already. So we publish a lot of work in IoT connected devices, whether that's a car or whether that's a ship. And I'm going to talk a little bit about shipping because there's a huge amount of relevance there. But just going back to the beginning, let's look at OT. And you probably see I've got a graveyard of old industrial controllers up behind me today. If you think about the history of OT, so often they were on separate networks. So they were physically isolated. They were kept very separate to the IT network. They worked for years. And in some cases, we're doing projects now that are involved in testing the security of OT environments where the previous iteration of equipment was 30 years ago, which is quite scary. We find they're very rarely updated. So even if they can be updated, you'll often find, for example, that there isn't enough memory on the system to support the latest patches and updates. They're designed primarily for uptime. They offer safety critical controls. Really, really important stuff here. So again, it's really important that we don't allow these devices to sit there and persist, because if they can't take security updates, we've got a real problem there, haven't we? It's not going to make life easy. Now, again, because they're isolated, it didn't matter so much. They were using protocols that weren't encrypted, but it didn't really matter. It wasn't a particular problem. But also, you had very unusual skills. So instead of looking for generalist IT networking skills, you're looking for really unusual skills, like those who can program ladder logic, for example. The ecosystems were tight per manufacturer. So typically, you'd see an industrial control system that was one brand. Maybe you had other parts, some other brands, but typically it was one installation from one organization. The ecosystem's tight, and you see gradual improvement in security over the years, but it's nothing revolutionary. So what about IoT by comparison? Of course, my lovely friend Kayla is here to help me with this part. Let's think about the changes. We've got an IoT ecosystem that's always connected. It's always on. In some cases, we don't see lifespans expected of 30 years or more. We see very short lifespans of products. They aren't often updated, or certainly weren't in the past. It didn't matter if they fell over because they came back up again quite quickly. The skills that were needed were quite generalist. They weren't specialist like OT. And the ecosystem is wide. I mean, think how many platforms there are for IoT management at the moment. And what was important was about getting to market fast and first. Innovate, get to market. So surely we wouldn't see the same mistakes as we're seeing in OT cybersecurity to IoT cybersecurity made in OT cybersecurity. Well, sadly, that's not the case. And I've got a great example for you here, which is why Kayla's come to assist me. You'll remember that Kayla's vulnerability stemmed from the fact that she used Bluetooth Classic, BT EDR, and she didn't have a Bluetooth security pairing pin. One area we're seeing increasing use of connectivity is in the area of electrical switchgear. Now, if you've ever been to a substation, you've ever seen a flashover. It's a very scary event, and people are injured, and in some cases have been killed by operating switchgear, particularly reclosers, for example. So a great move towards safety is to bring in a mobile app so you can actually trigger the switchgear remotely from outside the substation or some distance from the switch. So we had a look at these, we got pulled the software, had a quick look at the instructions to see how they work, and guess what the Bluetooth pin was? There wasn't one. So we're seeing exactly the same mistakes made in OT that we've seen made in IoT over the last few years. So a great safety case, but unfortunately undermined by someone not really thinking about security. Another great example, so we're seeing programmable logic controller manufacturers start to offer remote management of their PLCs using cloud services. Now, those of you who worked in IT security for a while have probably got their spidey senses tingling already. Now, we've started looking at some of these PLCs. Great idea, because it allows you to remotely administrate the platform, reduces maintenance costs because you don't need to send someone to site, which is fantastic. But of course, if you don't get the cloud security correct, you expose the security of the PLCs to people on the internet. We've looked at 4 different brands already. We haven't fully published all of our research yet. We've already found 3 of those with remotely exploitable hijack vulnerabilities. Very similar to some of our work you might remember on smart car alarms. We've discovered issues that allowed us to hijack the car alarm, take control of the car, kill the engine, bring the car to a halt, and pop the door locks, making theft of that car really quite easy. And yet we're finding these similar sort of vulnerabilities on cloud management in OT. Another very popular area you'll find are the concept of M2M devices. So again, allowing you to remotely administrate and manage your OT platforms and your resources. This is a vulnerability we found and disclosed about 18 months ago. Very similar skill sets required to reverse engineering IoT. Provide the lovely secure VPN router that would allow you to remotely connect to your OT outstations, connected over GSM or LTE typically. Unfortunately, once we'd reverse engineered it, we discovered that through static and weak encryption keys, we could remotely compromise nearly 300,000 devices, which was quite scary. And the vendor was not the most receptive when we disclosed the vulnerability to them. But again, this is a combination of 2 things. It's not just the vendor making mistakes. It's also the very fact these devices are on the internet in the first place. Operators of these devices, the installers of these devices need to get security sorted. Another real-time unit, an RTU, I'm not going to name them, but this is a good example of some vulnerabilities we found only a few weeks ago. The list of vulnerabilities is really quite scary. It's properly basic security fails, even remotely over the internet, could brick the RTU. And that's a device that's used for all sorts of remote telemetry into OT. Really quite scary stuff. And again, the point I made about devices being on the internet. So just use Shodan, the wonderful search engine for IoT and now OT. Pop onto the internet. If you know your search terms, you will find OT on the public internet in default configurations with weak passwords, stripping and switching industrial processes, whether they're power supplies, water supplies, or production processes. Quite worrying. Now, I'm going to take this talk off at a slight tangent in a minute. And one of the areas I want to start with is one of these devices. I think what's fascinating about IoT and OT is when you start seeing different industries start using technologies in slightly different ways. Now, typically when we're looking at a PLC, for example, on shore, maybe in a electrical supply environment, you'll find authentication on there. And you'll find an interface that you have to either brute force the password off or hope it's been changed from default. But imagine our surprise when we looked at one of these devices. This is a maritime specific PLC. And we started looking at it. It was typically used for managing onboard generation or hydraulic pressure controls, all sorts of fun things that these things do. And we were a bit shocked after having found some on board. We bought one on eBay. And on its management interfaces, which are on the network, it had no authentication at all. So you didn't even have to telnet, SSH, or anything onto it. You just connected to it, and there was 0 authentication. I mean, this is going back like 20 years. So I don't necessarily have problems with vulnerabilities, but what I do think vendors should do is manage disclosure well. And I think that's where the IOTSF and many other organizations have really helped drive disclosure processes in a positive way. We reported this to the vendor, and they said, it's on a ship. Physical security controls are enough. So What? What about VSAT and the fact that most ships are now connected to the internet? So yeah, physical, yes. Anyway, just not good enough. But then it got better. They said through our client we were working with that if you try and port scan it, it voids the warranty of the product. I'm like, wow, this is really not acceptable. And this is security disclosure and attitudes to vulnerabilities from 10 or 20 years ago. So we find different industries with very varying approaches to it. Now, I said that we talk a little bit about other industries. So we're going to go in a bit more depth into maritime now. And I want to talk about an exercise we did a little while back that we've affectionately named the Poseidon Adventure. And I'm sure you remember the 1970s movie where a ship was hit by a tidal wave and it turned itself upside down. And it was a classic 70s disaster movie. So we wanted to know if those sort of attacks could be carried out for real by a hacker. Now, you might remember a ship sinking in the outside Southampton, the port in the south of the UK. It was a car carrier called the Hugasaka, and it was taking cars from the UK to Germany on a circular route. The captain, as I understand it, misloaded the vessel, caused it to become unstable, and as soon as it went out into deep water, it made a turn, and the stability or the metacentric height was all off, and the vessel capsized. It was extremely lucky that the wind was blowing favourably, and the ship drifted onto a spit of sand, so it didn't capsize completely. What we've been looking at over the last few years are the OT systems on board. Typically, they're managing things like ballast control, so stability, propulsion, so the propellers are making it go, dynamic positioning, so that's the thrusters that move the boat around so it can moor. And we found all sorts of interesting devices, OT devices, that use unencrypted protocols using serial networks for potential exploits. This is the inside of one of the navigation system on a ship's bridge. It's called the ECDIS, or electronic charting system, and you can see there inside this Windows system PC are a bunch of serial connections. So there's all sorts of places where the serial and IP networks are joined up. If you read the manual, this is the manual for, I think, a Farino ECDIS, you can see lists of the various devices that talk serial unencrypted data. So you've got GPS, so position. We'll come back to that. You've got the ship's gyro, so the compass. You've got the logs, so depth and things like that. All really, really interesting things that you can tamper with. Now, you've all come across the idea of GPS spoofing, and in certain military installations, particularly prevalent around the Black Sea, GPS modification or jamming is carried out for military reasons. Now, that's great. You can do it. It's not particularly difficult to do with the right technology, highly illegal, obviously. But we wanted to look at whether you could tamper with the data on the vessel network itself. And we're typically targeting the serial to IP converters. Once you're onto the serial network, you can start tampering, you can start doing things that are all a little concerning. And we've done some demos, you'll see them on our website, where once you've got access to the ship's network, you can actually modify the GPS data that's received from the antenna onto the network and then passed onto the ship's bridge. And you can make the vessel appear to be somewhere it isn't. So this is a real ship's loading computer. All of those are the tanks on board. And if you think about a vessel as it uses fuel, as it loads and offloads, actually the balance of the vessel changes. So this is absolutely critical to making sure ships don't capsize in heavy seas or even on the flat. This is really, really important data. I'm going to come back to that in a minute. I want to talk about something else that's important first, the ICMS on board a vessel. Now, when you think about a ship's engine room, that's typically overnight called UMS, or unmanned machinery space, because you don't really want to be going in there. It's very noisy. It's not a particularly pleasant environment. Top right, that's a big ship's two-stroke diesel engine. Those are the levers that you use to take manual control. Very difficult to use. And in the middle there, you've got those big canisters. Those are the ship's start air. There isn't this concept of a starter motor on a ship's vessel. You just simply blow compressed air through the cylinders and it turns them over and off you go. But that's all a bit complicated and manual and not very efficient. So we use an ICMS on the bridge to control the engines and talk to the engine room, and that then manages the engine for you. So I wanted to show a really interesting set of vulnerabilities we pieced together from an exercise a while back, and how it allowed us to compromise the ship using vulnerabilities and misconfigurations in the ship's OT network. Now, on the left-hand side of this picture, this is actually a cruise ship. On the bottom, you see CS, those are cabin switches. There are lots and lots of switches, one for each cabin. There's then a rack of kits every few cabins that brings all the data together. So cabin switch is going to manage things like your TV, your internet in the cabin. It's going to manage your aircon. It's going to manage distribution of heating, for example, all really important things, including, very unusual one, ship's water. If you don't heat the water to a certain point on a vessel, you get problems with Legionnaire's disease and making everyone sick. Top left there, you see the VSAP, so that's how you get internet access. We'll come back to that bit in a minute. On the right-hand side, on a completely separate, segregated network, well away from all the cabins, is the shippy bit. So that's the controller management system that talks in the bridge to the engine room. I'm going to go into a bit more detail about how it does that. If you actually look in a bit more detail, the communication is done over serial, like most OT networks, and will then be encapsulated onto an IP network, transmitted through the conventional network, and then de-encapsulated and turned back into serial data that the control system understands. This is where things get interesting. Those encapsulation devices, serial to IP converters, often have vulnerabilities themselves. This is one of the most popular brands, very widely used, has been fixed now, but had an amazing set of vulnerabilities. You could change the passwords from default, but with local access to the device or even network access, you could actually reset the password to admin locally or remotely and then take control. And once you've got control of the IP converter, you can then start tampering with the traffic. So here's some of the fun things that we did. You'll remember we talked about loading earlier. Again, one of the most important systems on a vessel is the load computer, managing where the water is, where the fuel is, where the stores are. Every time the cruise ship loads with food, it needs to be carefully distributed and the ballast tanks managed so the ship is stable. So you've got a server for the load computer in a server room somewhere. And then you've got a user interface, which will be at the ballasting station, which will be somewhere else in the vessel. And those two things talk. Now, one of the challenges is getting two systems to talk. So an installer might look at this and go, great, okay, I'll just need to drill holes down through 7 decks. I need to make sure those deck penetrations are waterproof and fireproof, because that's really important. And I'm going to connect it to the server in the rack, and now I can control it over, serial. Great. Now, in this particular case, we think the installer didn't want to drill 7 deck penetrations because they're expensive to do and difficult to do. So they took advantage of a really interesting vulnerability that we discovered. They discovered that when you connect into any wall port at any point on the vessel, quite rightly, the vessel owner and operator decided they wanted 802.1x certificates on every single connection. Really good idea. It means you can only connect if you've got security. Fantastic idea. Really good for safety and security. If you connect and you don't have a recognized certificate, you get dropped into a tar pit, a black hole, if you like. And what had happened is, rather than drill these deck penetrations, the installer realized if they plugged into any wall port and they plugged the server into any wall port, they both went into the same tar pit. And that meant they didn't have to drill deck penetrations and took advantage of a security feature to communicate through a black hole in the ship's network. And what that meant was that we could plug into any point at any wall port on the network, get dropped into the same tar pit, and then we could tamper and take control of the loading computers. This was fun. Really, really interesting stuff, because we had control over all sorts of things. That allowed us to take control of the load computer server, so we now had control of the balance of the ship, so we could tip it over if we so wished. That then gave us control over things like the ballast tank levels, we have fuel tanks, and also things like hull stress. So it's really important to load a vessel evenly, otherwise you create torsion effects that can cause issues with the vessel. You can have bending moments that have actually sunk ships in the past, particularly when loading bulk carriers. If you load them in the wrong order, you break the back of the vessel. Anyway, that gave us all sorts of fun controls. That then gave us control and routing into the IP serial converters that I mentioned earlier. And that then gave us control of the engine room integrated control and management system. So from a load computer, we could affect the balance of the vessel, and we could also affect the propulsion. So we had complete control of a vessel, because a ship's installer tried to bypass certificate-based authentication because they didn't want to drill down through 7 decks. It's an amazing example of the operator specifying good security controls, the installer not understanding cyber, working around them, and as a result, anyone from any cabin on this vessel or any access port could take control of the ship. Funny, isn't it? absolutely bonkers. One of the big problems we find, and this applies to OT very much so, is we find bridging of networks. We find segregations broken down either by someone who didn't want to have to walk the length of the ship to query a vessel, a system, or the systems bridge networks by design. And on a vessel, a ship particularly, one of the most interesting areas for us is the voyage data recorder, because the black box of a ship records everything in the event that a ship has an issue. So if it goes down, there's a buoyant module that floats and takes all the information to the surface where it can be retrieved, and you can find out why the ship sank. A bit macabre, but still good to understand. And this is a voyage data recorder storage module. But of course, in order to get that data, it has to be able to connect to lots of different networks, the engines, the ballasting systems, the IT systems. Wonderful. So the very system that's there to assure the safety of a vessel can compromise its security if you don't get it right. And also we find enthusiastic engineers maybe bolting on a wireless access point so they can query a ship's status from their cabin from a mobile application. Really worrying. And I'm going to bring this all together in an exercise we did. This is an exploration drilling rig taken out into the deep ocean. It's drills to see if it can find oil or gas, for example. And then rather than anchoring itself, it uses dynamic positioning on thrusters to hold itself stationary, so it can actually stop itself moving without needing to send anchors right down to the seafloor. Really clever idea. And they're used to explore. If you find something valuable, great, we can now bring in an installation rig and exploit that. And a great example. So you see the thrusters down at the bottom. You see there's a control panel right down at the bottom of the stanchions. It's about 17 decks or 17 flights of steel stairs. It takes a good 10 minutes to walk all the way down. And what we discovered was an engineer had bolted in an unauthorized jump box so that they didn't have to descend all the way down to the bottom of the vessel in order to check the status of systems. So we came on board and noticed a cable had been taken out, what appeared to be the day before we'd arrived. And we discovered that the rig operator had not only bridged the networks, they'd connected them to a wireless access point, and even worse, had connected them up to TeamViewer so they could remotely over the internet administrate parts of the vessel. That was pretty scary. So we discovered bridging between beautifully segregated parts of the network. We find this very commonly on OT across the world. A great example of where IoT security and hardware security meet is a reverse engineering piece we did on one of the systems on this vessel. We often find industrial control switches used to segregate and provide security. This particular switch from Siemens, we looked at the admin passwords and we're a bit shocked to see when you increase the length of the password hash increased in length too. Now, if you know your password hashing, hashes are always the same length. So this intrigued us. We wanted to know more. So we went out and bought some ourselves, found JTAG, pulled the firmware, reverse engineered it. Took a couple of weeks, but one of my very clever colleagues called Chris reverse engineered the ARM, discovered the vulnerabilities in the way that the passwords are being set, discovered that instead of being hashed, they were being encrypted with a static key, ELS debug, meaning we could then, from any point on the network, exploit the switch, take control over it, route it, tamper with all the traffic, and that allowed us to compromise segregation on the network. In fairness, Siemens were really, really cool. They're one of the best vendors we've disclosed an OT vulnerability to over the years, perhaps because of their experience around the Stuxnet incident in 2008, 2009. They were really, really good. They acknowledged our report almost immediately, fixed it quickly, just brilliant. Hats off to Siemens. They did a really good job of managing vulnerability disclosure. That allowed us to compromise on this particular vessel from the internet into the corporate network. That allowed us to compromise their shore network as well. It gave us control of the drilling control network and also then upwards into the propulsion network. So OT is a scary place to be at sea. I kind of want to leave you with some points about what we can learn from this. We're seeing the same mistakes made in OT that we've seen in IoT over the years. We're seeing all sorts of issues with OT vendors announcing their big product sales to customers and then disclosing to the world which OT tech that the organization's operating. You might remember the Stuxnet incident from some press coverage from President Ahmadinejad inspecting the uranium enrichment facility. See those two valves in a photograph? We believe that was the start of what inspired the Stuxnet incident. Not so good. But we're seeing the same mistakes start to be made in OT as we're seeing in IoT over recent years. Moving from RTOS, which is much harder to compromise, moving more towards embedded Linux. So you're finding you're expanding the number of people who have the skills to hack your systems. We're seeing default passwords. We're seeing no concept of least privilege. We're not seeing firmware signing. We're not seeing secure boot impiled. There's no compile time hardening. So we're not seeing stack canaries and def and ASLR, for example. And also lots of dependencies through the software supply chain, embedding vulnerabilities.
Right.
Some thoughts?
That's been a really, really great, as I expected, a really good talk.